Hello. So in a previous video, we introduced the concept of compound inequalities. And today I wanted to, in this video, tack on a little bit more into the ideas and representations of particularly and inequalities. So if I were to have the two inequalities n is greater than 3 and n is, say, less than 5, remember I could graph this and say, okay, here is 3, here is 5. Has to be greater than 3 and less than 5 at the same time. That's what the and means, at the same time. And this is where n lives. Between 3 and 5. Now this is fun and good. However, this actually affords us, this language that we're using here, when we say n lives between 3 and 5, well, often in math, we write this as the following. N is between 3 and 5. N is greater than 3, but also less than 5. It's kind of boxed in here. It is what we oftentimes say bounded by 3 and 5. Now, why am I saying this to you? Well, oftentimes, this will be how we represent two inequalities that are, related in the and sort of way. Or maybe we're checking out the and relationship, the inclusive relationship where we consider both of them being true at the same time. Now, initially, we might be met with, for instance, something of the form, let's say, 2x plus 4 is greater than 6, and, so be greater than 1, and, for instance, 2x plus 4 is greater than 8, or sorry, let's say less than. So we can solve these through, and what you may notice is that I kind of already cheated a little bit. I kind of wrote the same expression here and here. I would wind up subtracting 4 from both parts of each inequality, because that would be the first step in isolating my variable, so I can get it into a form of, for instance, n being greater than or less than certain numbers. And I wind up with, well, in my first inequality, 2x is greater than 2. And in the other inequality, 2x is less than 4. I then divide by 2, 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 and I wind up as, or at, x is greater than 1, and x is less than 2, which on a graph we could do nice and good, 1, 2, the stuff between. And great, cool. However, this little notation here can actually be used right away. Because if you notice, we have a number here, that are sort of acting as bounds on these two, or in this, same expression. We have 2x plus 4, we have 2x plus 4. So you can really think that I have, for instance, 6 is less than 2x plus 4 is less than 8. Because here we have my expression 2x plus 4 is less than 8. That's right here. And 2x plus 4 is greater than 6. If you read it right to left, that is still true. Well, from here, if you notice, on each expression, I started by subtracting 4 from both sides to isolate my x. In this format here, I can do the same thing. I can subtract 4 from both sides here, and from both sides on the other expression, on the other inequality, and I get 2 is less than 2x is less than 4. And then I can see that I can divide by 2 here, so I do that. I get x is, well, greater than 1 and less than 2, and, well, this is what I ended up at over here. It is bounded by these two variables. And just notice how the representation here really matches what's going on here very well. We have like two endpoints that are firm numbers, and we are kind of stuck between them, bounded between these two numbers. And so I think this is a really nice form to work with when it comes to and inequalities. And do note, however, that this would not really work out if we use the OR inequality. We can't really force it into this same pattern, because if we did, well, let's kind of see what that would look like. If this was OR, perhaps we would have a graph that looks like this, where we have, for instance, n is greater than 2, and or n is less than 1. Well, it's kind of hard to piece these together because, well, if we tried, we'd see that, well, n has to be greater than 2, but it also has to be less than 1, but what numbers are less than 1? Well, 0 is less than 1, but is 0 greater than 2? No, it's not greater than 2. So this expression here is kind of just nonsense. I mean, we kind of see if n is the middleman here, then you imagine if we consider the endpoints, 2 should be less than whatever n is, which should be less than 1. But if n is less than 1, that means 2 should be less than 1. So really, we're really saying here that 1 is greater than 2, and that's not true. So when it comes to the OR expressions, we kind of have to leave them separate because there is no overlap there. There's no space in between these two expressions. If you look up here in the graph that I made for it, there's no space in between. In this representation here, this way to format your inequalities is saying that x is between 1 and 2, which match the original graph, which is our straight line between the two. And yeah,